Thank you for the opportunity given to us at the International Conference of Applied Science and Technology iCAST 2021. My name is Yusuf Wilson Mainas Rafael, and I'm from the Department of Civil Engineering, Polytechnic Negeri Kupang. The members of this research are Mr. Koilal Alokabel, Mr. Alpha Juventus Lucas, and Mr. Abia Erasmus Mata. On this occasion, I will present the result of our research entitled The Partial Substitution Influence of Fine Aggregate with Egg Tray Waste in the Green Concrete Production. Introduction. The increasing quantifier of urban population is not only caused by the high birth rate, but also the urbanization of society. With a high population, it will result in an increase in the volume of waste generated from home. Egg tray or egg packaging is one of the easy-to-find household waste, which is generally made from recycled paper waste in Indonesia. This condition is due to the high percentage of the highest amount of waste being in the category of paper waste and paper-based waste. Based on data from the Central Statistics Agency, the production of laying hen in Indonesia in 2020 reached a total of 5,044,394.99 tons. This figure does not include the production of native chicken eggs and duck eggs, which also always increase every year. This condition has shown that the use of egg tray will increase based on the demand for egg production, which in turn increase the volume of egg tray waste. The utilization of waste material as construction material has become a special concern, one of which is as a building material for green concrete. The term of green concrete is given to concrete made from the use of waste material, so that it becomes environmentally friendly concrete. Use waste material to make green concrete can be utilized through the replacement of cement, aggregate, pillar, or fiber reinforcement. Methodology. Research and sample testing was carried out at the Material Testing Laboratory, Department of Civil Engineering, Polytechnic Negeri Kupang, using local material for fine aggregate and coarse aggregate, and for cement using PPC Type 1. Egg tray waste use is obtained from household waste as well as from traditional market. Testing the characteristic of the material is carried out first to determine whether the quality of the material used has met the required specification standard. Mix design was carried out to obtain a compressive strength of normal concrete with target Fg 30 megapascal. The specimens were made in 4 sample variations for the percentage of egg tray waste, with variation of 0% for normal concrete, 1%, 3%, and 5% for variation of substitution of fine aggregate with egg tray waste. The egg tray waste used is clean of dirt, so that it remains in a clean state which is made into pulp to be mixed into the concrete. The percentage of egg tray addition is based on the ratio to the weight of the fine aggregate. Each sample variation was made as many as 8 samples of cylindrical specimen with a diameter of 10 cm and a height of 30 cm. The specimen was given treatment in water after 24-hour produce, and the compressive strength test was carried out at the age of 7 days and 28 days. For specimens with variation in the addition of egg tray, corrections are made to the water requirement based on the moisture content of the fine aggregate and egg tray. Due to the egg tray must be made into pulp before being mixed with concrete, so that the egg tray can mix well and become homogeneous with the concrete. Result and discussion. The specimen produced from each variation of the egg tray percentage as a substitute for sand in the concrete mixture shows different volume of test specimen within 24 hours after being poured into the mold as shown in figure 1. In normal concrete specimen and 1% egg tray percentage variation, there is no change in the specimen height, which is still according to the existing mold of 300 mm. However, for variation in the egg tray percentage of 3% and 5%, there was a decrease in the volume of the specimen, which has seen from the decrease in the sample height from the head of the mold. The 3% X-ray variation has an average specimen height to 298 mm, while the 5% X-ray percentage variation has an average specimen height of 296 mm. This shows that in the sample variation of the X-ray percentage variation of 3%, there is a shrinkage of 0.67%, and it is increasing in the sample variation in the X-ray percentage of 5% with shrinkage of 1.25%. The partial substitution fine aggregate with an X-ray can reduce the density of the concrete shown in figure 2. Based on the sample specimen, normal concrete has an average density of 2,403.47 kg per cubic meter. The replacement of sand with a percentage variation of 1%, 3%, and 5% X-ray result in a concrete density of 2,313.05 kg per cubic meter, 2,199 kg per cubic meter, and 2,105.72 kg per cubic meter. This shows that there is a significant decrease in the specific gravity of the concrete with the addition of an X-ray to concrete mixture. For the percentage variation of 1% X-ray, the specific gravity decreased by 4.36%. And with increase in the percentage variation of 3% and 5% X-ray, the specific gravity of the concrete decreased of 9.07% and 12.93%. Based on the result of testing the compressive strength of concrete for each sample variation shown in figure 3, it was obtained that the age of 7 days, the average compressive strength for normal concrete specimen was 28.86 megapascal. The specimen with variation in the percentage of X-ray as a partial substitute for fine aggregate of 1%, 3%, and 5% respectively were 23.95 megapascal, 9.75 megapascal, and 8.64 megapascal. At the age of 28 days of concrete for normal specimen, the average compressive strength of concrete is 36.14 megapascal, while for variation of 1%, 3%, and 8% X-ray, the average compressive strength of concrete is 31.29 megapascal, 14.46 megapascal, and 9.79 megapascal. Generally, there is an increase in the compressive strength of concrete from the age of 7 days to the age of 28 days. For the normal concrete, the increase in the compressive strength of concrete is 25.22%, while the increase in the compressive strength of concrete is more significant at 3% at 3% variation, which is 48.25%. In the variation of 1% and 5% X-ray, the compressive strength of concrete increased by 30.67% and 13.28%. Conclusion. Based on the result of this study, it can be concluded that X-ray waste can be used as a substitute for fine aggregate in making green concrete for structural concrete function. With a percentage of replacement of fine aggregate by 1%, the head a compressive strength value is close to normal concrete, while for X-ray 3% and 5% as substitutes for fine aggregate in concrete, it's not recommended for use as structural concrete. As the percentage of X-ray increases in the concrete mixture, the density of the concrete and the compressive strength of the concrete will decrease. Suggestion. Further research development needs to be carried out to determine the characteristics of fractural strength, splitting tensile strength, and modulus of elasticity produced with X-ray percentage variation below 1%. That's the end of my presentation. Hopefully, it will be useful for all of us. Thank you.